Welcome, weary traveler, to a quiet journey through the boundless expanse of the cosmos. Tonight, we invite you to close your eyes, relax your mind, and allow the gentle currents of the universe to carry you to distant, often unseen corners of existence. Your position grants you a terrifyingly privileged view, allowing you to witness the unbridled power of a stellar cataclysm unfold. As the soft whispers of space surround you, we will explore worlds far beyond our sun's comforting embrace, delving into their profound mysteries and the quiet truths they hold. Then, without warning, the sky would ignite. Imagine a colossal, invisible hand pushing through the interstellar medium. As the star's outer layers are violently ejected at incredible speeds, they create a colossal pressure front, sweeping through space like an unstoppable tsunami. This shockwave would ripple through nebulae, compress gas clouds, and stir up dust, literally reshaping the cosmic landscape in its wake. The stars were considered immutable, eternal beacons fixed in the heavens. It wasn't a comet which would move across the sky over successive nights. How could a new star appear in the supposedly immutable heavens? They carefully measured its position, confirming that it showed no parallax, no apparent shift against the background stars as Earth moved in its orbit around the Sun. This crucial observation proved that the new star was not a phenomenon within Earth's atmosphere, nor even within the solar system. It was one of the key pieces of evidence that paved the way for a more accurate, heliocentric understanding of the solar system and a universe that was far more vast and active than previously imagined. The legacy of Kepler's supernova extends far beyond its initial brilliance. It continues to be studied today with modern telescopes, revealing the remnants of that titanic explosion, teaching us more about the life and death cycles of stars, and offering a silent, glowing testament to a pivotal moment in humanity's quest to understand the cosmos. Its gentle, fading light whispers stories of scientific curiosity and the enduring wonder of a changing universe. But truly lay within the distant, supposedly unchanging realm of the stars. It was far beyond the moon, far beyond the planets, a genuine celestial novelty. This challenged deeply held beliefs about the perfection and unchanging nature of the celestial realm. Among the many who observed it was the great German astronomer Johannes Kepler, who would later meticulously study the phenomenon, lending his name to it. This was a fixed star, yet it shone with a brilliance that quickly surpassed Jupiter, then Mars, and eventually rivaled even the brightest stars in the night sky. For several days, it was so bright that it was visible even during daylight hours, a ghostly shimmer against the blue. He published his detailed observations in his book De Stella Nova in Pede Serpentari. In 1606, his work, alongside that of other observers provided critical data points that helped dismantle the ancient cosmology. It demonstrated that the heavens were not static and perfect, but dynamic and subject to change, even to violent and spectacular events. Comets were seen as atmospheric phenomena, portents or divine signs, never as objects beyond the moon's orbit. It was into this cosmological framework that a new, brilliant star suddenly appeared. If any celestial bodies were unfortunate enough to be in its direct path, perhaps a small, rocky planet or a gas giant, they would be subjected to unimaginable forces. Their atmospheres could be stripped away, their surfaces scorched, and their very structures fractured by the sudden, intense pressure. Moons might be torn from their orbits, or even vaporized into superheated plasma. A sudden, blinding flash of light would erupt, so intensely brilliant that it would momentarily eclipse all other stars, even those in distant galaxies. Familiar constellations might be obscured by glowing debris, and the subtle gravitational dance of planets and asteroids would be violently disrupted. Yet, amidst this destruction, there is a terrifying beauty. The expanding shell of gas and dust, illuminated by the dying star's final gasp, would paint the void with ephemeral colors and intricate patterns, a celestial artwork born of pure cosmic violence. It is the ultimate expression of a star's death, a dramatic alteration of the very fabric of space, humbling in its scale and overwhelming in its power. To witness such an event, even from a cautious distance, is to be confronted with the sheer, untamed forces that silently shape the vast, indifferent cosmos around us. It is a moment where the terrifying grandeur of the universe is laid bare, reminding us of the fragility of quiet existence in the face of such immense, beautiful, and destructive power. This is not the gentle glow of a new dawn, but a furious, all-encompassing brilliance, capable of overwhelming sensitive instruments and, theoretically, any unprotected vision, even from what we might consider a significant distance. This is the story of Kepler's supernova, officially designated SN 1604, the last supernova observed with the naked eye within our own Milky Way galaxy. Its appearance was not just a scientific curiosity, but a profound cultural and intellectual upheaval in a world still grappling with its place in the cosmos. The star, which perhaps moments before was a familiar twinkling point, would balloon into a monstrous, luminous orb, radiating energy across the electromagnetic spectrum, from the gentlest radio waves to the most potent gamma rays. Let the tranquil rhythm of the cosmos guide your thoughts, allowing your consciousness to drift as we explore the vast tapestry of stars, galaxies, and the silent, wandering worlds that define our universe. This isn't just visible light. It's a torrent of high-energy particles, X-rays, and gamma rays. If you were closer, this invisible assault would be devastating, stripping atoms from molecules, disrupting delicate biological processes. Even at a safer distance, you would sense its profound presence, a silent, pervasive energy that permeates everything. It's a chilling reminder of the raw, untamed power that defines the universe at its most extreme. Imagine yourself for a quiet moment within a cosmic vantage point, a safely distant, yet observably close position to one of the universe's most monumental events, the explosive death of a massive star, a supernova. Before the main event, there would be a subtle, almost imperceptible shift in the star's light, a fleeting moment of quiet anticipation in the cosmic theater. Following this initial burst of light, an immense wave of radiation would wash over your location. And then, after the initial flash and the invisible flood of radiation, comes the cosmic shockwave. The immediate, catastrophic effects are profound. The region around the dying star, once a relatively stable stellar neighborhood, would be utterly transformed. From the hypothetical vantage point of a supernova's immediate, overwhelming power, we gently transition to a very real, historical event, celestial drama witnessed by human eyes, whose quiet echoes still resonate through the annals of astronomy. The year was 1604. Europe was a continent of burgeoning scientific thought, yet still deeply entrenched in the ancient Aristotelian view of a perfect, unchanging, celestial sphere. On the night of October 9th, 1604, observers across Europe began to notice a startling new light in the constellation of Fucus, the serpent bearer. The appearance of this new star, or nova stella, as it was called, caused immediate consternation and excitement. Kepler, alongside other astronomers of the era, like Galilei, understood the profound implications. Kepler spent over a year observing the supernova, meticulously documenting its gradual fading. The impact of SN 1604 was immense. It fueled the scientific revolution, encouraging a new spirit of empirical observation and challenging dogma. It was one of the key pieces of evidence that paved the way for a more accurate, heliocentric understanding of the solar system and a universe that was far more vast and active than previously imagined. The legacy of Kepler's supernova extends far beyond its initial brilliance. It continues to be studied today with modern telescopes, revealing the remnants of that titanic explosion case, teaching us more about the life and death cycles and offering a silent, glowing testament to a pivotal moment in humanity's quest to understand the cosmos. Its gentle, fading light whispers stories of scientific curiosity and the enduring wonder of a changing universe. From the historical observations of Kepler's supernova, we now quietly delve into the profound scientific wonders unleashed by these colossal explosions. While seemingly destructive, supernova are, in fact, the universe's most prolific creators, acting as cosmic crucibles where the very building blocks of life are forged, and as powerful engines that ignite the birth of new stars and planetary systems. Imagine a star throughout its long life. For most of its existence, like our Sun, it fuses hydrogen into helium in its core. This outward shockwave, combined with a flood of neutrinos, blasts the star's outer layers into space. It is during this violent, fleeting momenta fraction of a second that the most remarkable cosmic alchemy occurs. The shock waves, propagating outwards from a supernova explosion, are immense. As the cloud collapses, fragments within it begin to heat up, eventually becoming protostars. The violent death of one star provides the raw materials and the energetic kickstart needed for the birth of countless new stars and, crucially, for the formation of new planetary systems that are rich in the heavy elements necessary for complex chemistry and, potentially, for life itself. These are not merely abstract concepts. They are tangible components of who we are. When these massive stars explode, they don't just create new elements. They scatter them across vast stretches of interstellar space. The carbon atoms that form the complex molecules of your DNA, the very blueprint of your being, were once part of a stellar furnace that exploded billions of years ago. We are not separate from the cosmos. We are an integral, evolving part of it. It speaks to the intricate interconnectedness of all things, from the smallest atom to the largest galaxy. It reminds us that even in the vastness and the apparent indifference of space, there is a fundamental elegance to the universe's design, a continuous flow of matter and energy that leads to ever-increasing complexity. The silent explosion of a distant supernova billions of years ago set in motion a chain of events that eventually led to your conscious awareness. Pondering these very thoughts, we are the universe, in a sense, experiencing and understanding itself. The very processes that create and destroy stars are the same processes that ultimately enabled our existence. From the fiery demise of colossal stars to the quiet formation of the very elements within us, the universe endlessly transforms and creates. May the profound realization of your connection to this cosmic tapestry now guide you towards a tranquil rest, a gentle sleep as you drift in the peaceful expanse of your own inner universe. Good night, the universe. In its grand, cyclical dance, constantly recycles its fundamental components. Stars are born, live their lives, and die, often violently, only to give birth to new stars, new planets, and new possibilities for life. We are, quite literally, made of star stuff, Carl Sagan famously coined this phrase, and its poetic simplicity belies a profound scientific truth. Every particle that makes up your hand, the air you breathe, the chair you sit on, and the device you're listening to this on, traces its lineage back to the heart of an exploding star. These enriched clouds of gas and dust then become the raw material for the next generation of stars and planetary systems. Our own sun, a second-generation star, formed from one such cloud. A nebula already infused with the heavy elements produced by earlier supernova. And within that same nebula, the early Earth coalesced from those very same elements. For billions of years, the universe, shortly after the Big Bang, consisted almost exclusively of the lightest elements, hydrogen and helium. These early stars, immense and short-lived, fused hydrogen into helium, and then, in their final cataclysmic moments as supernova, they forged the heavier elements. Without these cataclysmic events, the universe would be a far simpler, less diverse place, perhaps consisting only of hydrogen and helium, devoid of the intricate molecular structures that make up everything we see, touch, and are. The quiet, profound truth is that every atom of iron in your blood, every speck of silicon in the rocks beneath your feet, and every molecule of oxygen you breathe carries the silent, ancient legacy of a distant, stellar explosion. Around these newly forming stars, the leftover gas and dust, now enriched with the heavy elements forged in the supernova, begin to flatten into protoplanetary disks. An humbling realization. The intimate, inescapable connection between these distant cosmic explosions and the very essence of our own existence. This segment invites a philosophical reflection on the idea that every atom in our bodies, every speck of dust on our planet, and indeed every star and galaxy we observe, calent legacy of these stellar deaths. It is within these disks that new planets will eventually coalesce, building up from the very elements scattered by the earlier stellar explosion. As these shock waves sweep through the vast, diffuse clouds of gas and dust that permeate interstellar space, they act as cosmic snowplows. They compress these tenuous nebulae, pushing its density. When a gas cloud reaches its density, when a gas cloud reaches a certain critical density, its own gravity begins to take over, causing it to collapse further. The extreme temperatures and pressures generated by the explosion create the perfect conditions for a rapid burst of nucleosynthesis. Lighter elements are bombarded with neutrons and other particles, rapidly building up into heavier elements that simply cannot be forged in the calmer cores of living stars. As a massive star ages, it begins to fuse heavier and heavier elements, helium into carbon, carbon into oxygen, and so on, building up layers like an onion. This process continues until the star's core is primarily iron. Iron is a crucial turning point because fusing iron requires more energy than it releases. At this point, the star's internal fusion furnace ceases to produce the outward pressure needed to counteract the immense inward pull of its own gravity. At the heart of a supernova's creative power lies a process called nucleosynthesis. What happens next is cataclysmic. The core collapses in on itself with incredible speed, triggering a massive rebound. Think of the elements essential for life as we know it. Carbon, the backbone of organic chemistry. Oxygen, vital for respiration. Iron, essential for blood and planet cores. Silicon, the basis of rocks and minerals. And heavier elements like gold, silver, and uranium. All of these, and many more, were primarily created in the fiery heart of a supernova explosion. Our Sun, a relatively young star, does not have the mass to create these heavier elements within its own core. It inherited them from previous generations of massive stars that lived, died, and exploded billions of years before our solar system even formed. But supernova don't just create elements. They also act as cosmic gardeners, planting the seeds for future generations of stars and planets. This gravitational collapse leads directly to the formation of new stars. This cycle highlights a profound cosmic paradox: destruction leading directly to creation. Having quietly explored the destructive yet creative power of supernova, we now arrive at perhaps the most profound. Consider the elements we discussed: the carbon that forms the basis of all organic life, the iron that courses through our blood, the calcium in our bones. The spectacular, destructive beauty of a supernova is, in essence, a cosmic recycling event. This means that the iron in your hemoglobin, allowing your blood to carry oxygen throughout your body, once resided in the core of a long-dead star, forged in its final, fiery moments. This profound connection fosters a deep sense of belonging within the universe. As the echoes of a distant supernova gently fade from your awareness, allow the vast, cyclical dance of the cosmos to settle your thoughts. From the fiery demise of colossal stars to the quiet formation of the very elements within us, the universe endlessly transforms and creates. May the profound realization of your connection to this cosmic tapestry now guide you towards a tranquil rest, a gentle sleep as you drift in the peaceful expanse of your own inner universe. Good night.